Verification of KCL and KVL. Aim: to verify the KVL and KCL theoretically and practically for the given circuit. Apparatus required: trainer kit, ammeter, DC digital ammeter of 0 to 200 milliamperes of one number. By using only one ammeter, we are measuring the current flowing through the each element and total current. Voltmeter of digital 0 to 30 volts of one number. Resistors. Now based on the circuit, if it is two resistors, then we need the trainer board. We have two resistors of 1 kilo ohm and 1.8 kilo ohms. If the circuit is consisting of three resistors, 1 kilo ohm, 1.8 kilo ohm and 2.2 kilo ohm. Based on the given resistors, we have to take the resistor values. Connecting wires. Kirchhoff voltage law states that the algebraic sum of voltages around any closed path in a given circuit is always 0. In any circuit, voltage drop across the resistor always have polarities opposite to the source polarity. When the current passes through the resistor, there is a loss in the energy and therefore a voltage drop. In any element, the current flows from higher potential to lower potential. Kirchhoff current law. Kirchhoff current law states that the sum of currents entering a node is equal to the sum of current leaving the same node. Consider the figure shown in figure, where there are three paths according to the Kirchhoff current law. I1 equals to I2 plus I3. Circuit diagram for KCL if two resistors are given in the question. Circuit diagram for KCL if three resistors are given in the question. Procedure for KCL. Make the connections as per circuit diagram. Switch on the power supply and adjust the supply voltage to 12 volts. Take different values of resistors. If there are two resistors in the circuit, take two resistors. Otherwise, in the circuit, if in the question if it is three resistors, then take the three resistors of 1 kilo ohm, 1.8 kilo ohm and 2.2 kilo ohms and measure the current flowing through each resistor and add on the readings of total current I1, I2 and I3 using ammeters and verify Kirchhoff current law. Tabulate the readings and compare the theoretical values and practical values. Trainer board. From supply, positive is connected to voltmeter positive, negative is connected to voltmeter negative. It is used to measure the supply voltage. The voltmeter is used to measure the supply voltage. Now connected from positive to the circuit diagram. KCL Kirchhoff current law circuit diagram. Positive, battery positive, negative, black is connected to black. Next, ammeter positive is connected to 0 to 200 milliamperes, ammeter positive in the circuit diagram. Negative is connected to 0 to 200 milliamperes, black, negative. Connect a resistance of 1 kilo. Red is connected to red and second terminal of resistor is connected to the yellow of the 1 kilo resistance. Second resistance of 1.8 kilo ohm is connected to second resistor also. Now short circuit the ammeter 1 and ammeter 2. Ammeter 1 is connected in series with 1 kilo ohm resistance. Ammeter 2 is connected in series with 1.8 kilo ohm resistance. Switch on the power supply. Now place the RPS voltage to 12 volts. Since the ammeter is connected, this ammeter will measures total current, which is 21.8 milliamperes, which is total current. This is the total current flowing through the circuit, 21.7 milliamperes. Now again switch off the power supply, and now we will measure the current flowing through the 1. Now we will short circuit this total current ammeter reading, and we will place the ammeter that is in series with 1 resistance, and we will short circuit the main ammeter, which is total current ammeter, to close the circuit. Again switch on the power supply, and note down the I1 current, which is 14.2 milliamperes. Now again switch off the power supply. Now measure current flowing through the 1.8 kilo ohm resistance by short circuiting the 1.2 kilo ohm resistance ammeter, and we are just replacing, and we are short circuited the 1.2 kilo ohms resistance ammeter. Again you switch on the power supply. Now we will measure current I2, which is equals to 7.9 milliamperes. Now if this question is for resistors are in the question, if there are 3 resistors are there, now connect the third resistor, which is 2.2 kilo ohm resistance in the third element. Again here also short circuit the ammeter with the help of F wire, that is I3. Now first of all we will measure the total current. We will place an ammeter, which is to measure the total current I1, I2 and I3. All the 3 ammeters are short circuited. Now switch on the power supply, and we will measure the voltage increase of 12 volts. Total current is 27.6 milliamperes. Now switch off the power supply. Now we will short circuit the total current ammeter, and we will measure the current I1. Therefore I1 is equals to, we will measure I1 by switching on I1. The value of I1 is equals to 13.9 milliamperes. Similarly we will switch off the power supply, and we will connect an ammeter that is in series with, that is I will measure the current I2, and we will short circuit the I1 and I3's ammeters. Again by switching on, you will measure the current I2. I2 is equals to 7.7 milliamperes. Third case, which is I3 is equals to, similarly to measure I3 we replace We'll connect an ammeter that which is connected in series with R3, and we will short circuit the I2 ammeter. Therefore, we will measure current I3. I3 is of 6.3 milliamperes. This is of KCL Kirchhoff current law. Now reduce the voltage to 0 and switch off the power supply. Theoretical calculations for KCL. I equals to V by R. I1 is equals to V by R1 is equals to 12 by 1.2 kilowatts, which is 1.2 into 10 cube, which will give 10 into 10 power minus 3 amperes, which is 10 milliamperes. Current I2 equals to V by R2. V is 12 volts, R2 is 1.8 into 10 cube, which is equals to 6.66 into 10 power minus 3 equals to 6.66 milliamperes. Therefore, total current IT is equals to I1 plus I2. I1 is 10, I2 is 6.66, which is 16.66 milliamperes. We can find out the value of total current by finding R equivalent. Then 1 by R is equals to 1 by R1 plus 1 by R2. Therefore, R equivalent equals to R1 R2 by R1 plus R2, which is equals to 1.2 into 1.8 by 1.2 plus 1.8, which is equals to 0.72 into 10 cube, which is equals to 0.72 kilo ohms. Since the values of resistors are in kilowatts, IT is equals to V by R equivalent, which is V is 12 by 0.72 into 10 cube, which is equals to 16.66 into 10 power minus 3 amperes, 16.66 milliamperes. Now note down these values in the table. I1 is equals to V by R1. V is 12 volts. Resistance is 1.2 into 10 cube, which will use 10 into 10 power minus 3, which is 10 milliamperes. I2 equals to V by R2. V is 12 volts. R2 is 1.8 into 10 cube, which is equals to 6.66 into 10 power minus 3, which is 6.66 milliamperes. I3 is equals to V by R3, 12 by 2.2 into 10 cube, which is equals to 5.45 into 10 power minus 3, which is 5.45 milliamperes. Total current IT is equals to I1 plus I2 plus I3, which is equals to 10 plus 6.66 plus 5.45, which is equals to 22.12 milliamperes. To find out total current, we can able to find out by using R equivalent. 1 by R is equal, R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R is equals to 1 by 1.2 plus 1 by 1.8 plus 1 by 2.2, which will use 1.843 into 10 power minus 3, because this is in kilo ohms. 1 by R equals to, therefore R equals to 0.542 into 10 cube, 0.542 kilo ohms. This is R equivalent. Total current IT is equals to V by R equivalent. V is 12 by 0.542 into 10 cube, which will use 22.12 into 10 power minus 3, 22.12 milliamperes. Note down these values in the table. Circuit diagram for KVL if two resistors are given in the question. Circuit diagram for KVL if three resistors are connected in the question. Procedure for KVL. Make the connections as per circuit diagram. Switch on the power supply and adjust the supply voltage to 12 volts. Here in the question it is of 12 volts is given. Take different values of resistors R1, R2, R3 of 1 kilo ohm. 1 point. Take different values of resistors. If it is two resistors, take two different values of resistors. If it is three resistors, take three resistors of kilo ohm, 1.8 kilo ohm and 2.2 kilo ohms, and measure the voltage across each resistor and note down the readings of V1, V2 and V3 by using voltmeter and verify the Kirchhoff voltage law. Tabulate the readings and compare the theoretical values and practical values. If there are only two resistors, measure the voltage across each resistor and note down the readings of V1 and V2 using the voltmeter and verify the Kirchhoff voltage law. Coming to KVL. Supply positive is connected to the battery terminals. The first resistor of 1 kilo ohm and the current second resistance of 1.8 kilo ohm and connect third now the third resistance is replaced with a short circuit, since we are having two resistors in the circuit. Now here if you switch on the supply, now here you will use only 1 voltmeter. Now to measure the supply voltage, we will connect the voltmeter is connected across the supply voltage by switching on and by placing the rate in the RPS. We will measure the voltage, we will fix the voltage, of 12 volts, which is supply voltage 12 volts. Switch off the power supply and connect the voltmeter across R1 to measure voltage V1. Now we will measure V1 equals to, by switching on power supply, we will measure V1 equals to 4.2 volts. Again switch off the power supply and connect voltmeter across R2, which is 1.8 kilo ohms, across R2. V2 is, now we will switch on and we will measure the voltage. V2 is 7.7 volts. Switch off the power supply. If the circuit is consisting of 3 resistors, then connect a third resistance of R3 is equals to 2.2 kilo ohms. Again, to measure voltage V1, the voltmeter is connected across, we are already given supply voltage, which supply voltage is 12 volts. Now to measure V1, the voltmeter is connected across R1 ohm, and by switching on, we will measure the voltage V1 is equals to 2.2 volts. Again by switching off, measure the voltage across R2, which is 1.8 kilo ohms, V2, which is equals to 4.3 volts, and switching off, and to measure the voltage across R3, which is 2.2 kilo ohms, V3 is equals to 5.3 volts. These are the practical values. By substituting the theoretical values and practical values, this is a tabular column. If 3 resistors are connected in parallel. Theoretical calculations for if 2 resistors are connected in series. It is for KVL. R equivalent is equals to R1 plus R2. Since 2 resistors are connected in series, 1.2 plus 1.8, which is equals to 3 kilo ohms. I equals to V by R equivalent, which is V is 12 by 3 into 10 cube, which is equals to 4 into 10 power minus 3, which is 4 milliamperes. is the current. V1 is equals to I into R1, 4 into 10 power minus 3 into R1 is 1.2 into 10 cube, which is equals to 4.8 volts. V2 is equals to I into R2, 4 into 10 power minus 3 into 1.8 into 10 cube, which is equals to 7.2 volts. Vt is equals to V1 plus V2, 4.8 plus 7.2 is equals to 12 volts. If three resistors connected in series, note down these values in the table. If three resistors connecting in series, then R equivalent is equals to R1 plus R2 plus R3. R1 is 1.2 kilo ohms, R2 is 1.8 kilo ohms, R3 is 2.2 kilo ohms, which is equals to 5.2 kilo ohms, 5 into 5.2 into 10 power 3 ohms, 5.2 into 10 power 3 ohms. I equals to V by R equivalent EQ is equals to V is 12 by R equivalent is 5.2 into 10 cube, which is equals to 2.307 into 10 power minus 3. 2.307 milliamperes. Voltage across R1, V1 is equals to I into R1. I is 2.307 into 10 power minus 3 into R1 is 1.2 into 10 cube, which is equals to 2.76 volts. V2 is equals to I into R2, 2.307 into 10 power minus 3 into 1.8 into 10 cube, which we can obtain 4.15 volts. V3 is equals to I into R3, 2.307 into 10 power minus 3 into 2.2 into 10 cube, which is equals to 5.07 volts. Vt is equals to V1 plus V2 plus V3, 2.76 plus 4.15 plus 5.07, which is almost equals to 11.98, is almost equals to 12. Now note down these values in the table. Precautions: avoid loose connections. Check whether all knobs are in minimum position or not. Check all the connections before switch on the power supply. Result: hence KVL and KCL are verified theoretically and practically for the given circuit. Conclusion: since the values of theoretical values and practical values are different due to the tolerance in the resistance. Thank you for watching. Please like, share and subscribe if you like.